Hello, it's Duncan. Today in Java to Kotlin, we're going to look at converting code that uses Java optional to Kotlin, and then removing the use of the optional in favour of Kotlin's nullability support. This is based on chapter 4 of Nat Price in my book, Java to Kotlin, a refactoring guidebook, and the title of the chapter is Optional to Nullable. So let's have a look at the code. So let's have a look at the code that we want to convert. This is reasonably typical Java. It's a static method in a class called legs, so it's supporting operations on collections of legs in this case, and a leg is a part of a journey, and the thing we're interested in really particularly here is just its duration. That's all we care about. What does this method do? Well, it takes a list of legs and finds the longest one over a particular duration. And it's being used in our code somewhere to find the worst part of a journey so that we might offer an alternative to it. Now, the reason this returns optional is because this list of legs may be empty. Or it may not be empty, but none of the legs are over the duration. And in those cases, we need to say, well, we couldn't find a leg that matched this specification. And our way of doing that in Java 8 is, Java 8 and later, is to return an optional. We could return null, and in fact, you'll see inside here the code uses null and only wraps right at the end. But if we use null, we've got no way of signaling in Java that this leg can be null or can't be null, because every reference in Java could possibly be null. In Kotlin, though, of course, we could mark this as a nullable leg, a leg question mark, and then our code would know that it could fail. This method could not be able to find a result, and the compiler would make us take notice of that, make us account for it, in the same way as, in fact, Java does when we use optional. So let's look at where this code is called, and we've separated that as only really the tests left now. And we're going to use the tests as a proxy for all of the production code there could be. Here are the tests, and you'll see that we show that if you call this on an empty list, then the result is optional empty. If you call it on a list where there is no item that is over duration of 1 day, in this case, we return optional empty. Otherwise, we don't return optional empty, we return an optional that has a thing in it, and Java then makes us account for that before we can call the description to find out we got the right one. And in this case, we're accounting for it by calling or else throw. We could call get. There are a number of different operations we can do on an optional, but the key thing is that we're forced to consider the fact that it's not just a leg, it's a leg or maybe not a leg. So we want Kotlin nullability support, so we are going to have to convert something to Kotlin, and legs is a good place. So we'll say convert Java to Kotlin. And IntelliJ offers to convert anything else that needs to be converted to make this work, and then fails to compile for reasons that I really don't understand. But fixing imports fixes that. Let's take a look at the code that's generated. It's put it in an object called legs and marked it as JVM static, this converted method, and that allows, if we look commit, that allows our Java code in the test to not change at all. So previously it had imported legs, longest leg over, and it can still import that because this Kotlin is in a JVM static in an object. That's not very idiomatic Kotlin. We wouldn't normally put something into a top level class like that, but let's first of all see whether, just check we can run the tests. That's fine. So to be more idiomatic Kotlin, we'd like to move this out, and there's a refactor to do that, which is move to top level. Unfortunately, it doesn't work. And it doesn't work because it hasn't noticed that it needs to take this with it into the top level. It also hasn't worked because it hasn't noticed this is JVM static, and that's not an annotation you can apply at the top level. But apart from that, everything has been fine. So we're going to fix things up for IntelliJ. We're going to delete that, and we're going to move this to the top level as well. And then it's no longer in there, so we'll fix that. And check that does work. There's a little bit of odd formatting here as well that we can fix up. Now let's go back and look at longest leg over tests, our Java client code. And you'll see that this has actually changed. So previously this was importing from travelator legs, and now it's importing from travelator legs KT, which is the class that Kotlin invents, if you like, to hold these top level functions. That's a little bit ugly, and we can fix it by adding an annotation here to tell Kotlin what to do instead, and that is at file JVM name, passing it the name that we would like this to be, legs rather than legs.kt. And if we do that, then we can revert our Java code to the previous, and that will all build and run. So now we're in a position where we've converted our Java to Kotlin, but our Java clients haven't had to change at all. This is entirely unchanged, which is good news for our projects because it means we won't have to ripple these changes through all our code. Now before we go on, we're just going to make this a little bit nicer Kotlin. First thing we can see is this compare to could be replaced, and this is only called from Kotlin, so we could make this a receiver, and now we can call it as leg is longer than plan duration. Leg is longer than plan duration. To be honest with you though, I think like this, it's not really pulling its weight at all, so we can inline this, and now we've got rid of another method. Run that. Everything is fine. Also though in Kotlin, we could make this the receiver of this method. So now we have an extension method on list of leg, which is find longest leg over some duration. What's interesting though is that that hasn't changed our Java at all either. So our Java code here was importing find longest leg over, and whereas Kotlin would say list dot find longest leg over duration, in Java we can pass the receiver, the thing that we appear to be calling an extension function on, as the first argument, and everything still works. So again, so far we've tidied up this code really quite a bit. It's certainly shorter, it's quite a bit nicer in Kotlin, but our Java clients haven't had to change at all, which is lovely. Now let's look at converting this method to return a nullable leg rather than optional leg. Luckily for us, in fact, we already have that code and it's sitting in the middle of here. So we could extract a method here and we could call it find longest leg over. I say we could call it that, but of course we can't, because we can't have two methods called the same thing with a different return type. So we back that out and do it again, and this time we're going to call it longest leg over. Let's just remove the find for now. Now we can inline that, and in fact we can make this a nice expression body, really nice and small. Now we have two functions, one that we can call from Java and one, well, we can still call it from Java, or at least we could if we made it public. And what we're going to do here is we're going to keep these both around until all of our client code is calling this one, and then we'll be able to delete this one. And that we call expand contract refactoring. So Java is currently calling this version. We'll split this and show both at the same time. And let's look at how our Java could be calling the Kotlin version. Well, we can show that by just inlining this one. Except it turns out we can't inline a reference from Java, Kotlin to Java, which is, I suppose, understandable but a shame. So let's cancel that. And instead we will just go straight to the Kotlin version and say we're going to call longest leg over. That's wrong. We can make it right by making that public and then importing that. Now, even IntelliJ knows that this is not going to go well because we're actually returning a leg here and we're comparing it with optional empty. We can run the test and show that it was right. So that will fail. Now we can solve that problem by calling this optional dot of nullable here, and that will fix this up quite nicely. Alternatively, of course, we can call longest leg over directly and compare it to null. We should be careful about this in Java because if we're calling this version directly, we don't know. Java isn't warned that this might be returning null. Having said that, you'll see that if we were to replace this with something like getDescription, there is a warning here that the method invocation getDescriptor may produce null pointer exception. And that's because the Kotlin compiler has annotated this method in the bytecode to tell Java that this may be returning null. So we sort of get the best of both worlds. But let's for now go with this version, which is good, and then IntelliJ will also tell us that that could just be assert null. Over time, of course, more and more of the client code will end up in Kotlin, and we'll simulate that by converting this test to Kotlin. See if we can run that. Again, some issue with imports. But apart from some warnings, that works. It's also thrown away some white space that we rather liked, so let's just pick that out. And now a little warning here that we could be using list of rather than Java util list of. And that will leave this unused. And we talk in the book about how Kotlin maps its own collections to Java collections and vice versa. We won't get into that today. Okay, there will be times in Kotlin where we have something that returns null and we really need an optional to pass it to a Java API, for example. In this case, we're using it in this test. So we could pull this code out into a method, and we'll call it toOptional. And then the subject of this we'll pull out into a parameter. What is that? Well, that's just a thing as far as we're concerned. And we don't care its type, so we'll replace the leg with a T question mark. And just to check, we'll say, what is the return type of this? Well, that's optional of T. Not quite done, because in Kotlin this can become an extension function. And now you can see this code reads quite nicely. We're taking the empty list, we're taking the longest leg over, and we are converting to optional. This is a nice piece of utility to put in our production code. We'll move it over here. And in fact, that is exactly what we're calling here, so we can move this over as well. Run the tests. Splendid. Of course, now all of our client code is in Kotlin, as there's only our tests here. We don't really want this version anymore, this find longest leg over returning optional, because the Kotlin compiler will tell us when things can be null. So we can fix this as we did before by saying this is null, and we can remove the optional. And that was already the code we had here. So let's import those. For some reason IntelliJ isn't suggesting we could assert null on this, but we do it ourselves. Passes. Moving down the file, we have the places where the optional isn't empty, and because it isn't empty, we're calling or else throw here before we get the description. And or else throw is defined to throw a no such element exception if the value isn't present, which is to say if it's empty, which it won't be because there is, in this case, a leg that's over. The Kotlin equivalent of or else throw is bang bang, so let's call the Kotlin version, which is longest leg over. That isn't returning an optional, so there is no or else throw, but instead of that we'll say check that's not null and get the description. We run that, it passes, but if we were to make the test fail, and it fails in this case with a null pointer exception, not the no such element exception that the Java code fails with. This is just a different way of thinking about something not being there. Probably shouldn't use bang bang in production code unless we're really certain that something can't be null and we don't care about any error messages. So in this version here we'll use longest leg over, and instead we'll use question mark dot, and question mark dot evaluates the left hand side, evaluates the right hand side only if the left hand side isn't null. So I need to revert that. So this succeeds, but if it hadn't succeeded, the value of that expression would be null. It's that here, it expected one day, actually got null because this is not going to evaluate the description. If we want a better behavior than that, we can use the Elvis operator, which is question mark colon, and that will take the null that comes out of here if this is wrong and only evaluate the right hand side if that is null. So we can use that to return a different result in this case. Banana, you'll see we get out this case, or often we'll use that to raise an error, or we can use that to raise an error with a message that makes sense to us in production. Let me fix that. Splendid. Little bit of tidying, and it would unusual for these things to sit in a companion object in Kotlin, so we would tend to move that out just as a top level function. Could be a method equally. Now of course our optional returning version is unused, so we can now enter the contract stage of our expand contract refactoring and delete this one because none of our clients need it. So that's the end of pushing out the optional in favour of a nullable leg. Can we do better than this code in Kotlin just to tidy things up? Delete this as we don't need it at the moment. I'd like to say that I'd found a nice refactoring, but to be honest with you, I haven't. What I have found though is a way to express this that makes more sense than I think than the for loop, and is more immediately obvious. But in order to be safe, we'd have to have good tests, and I think we probably do have good tests looking at this. We're testing the key conditions here. So the name of the method is longest leg over. So in order to re-implement this, we're going to find the longest leg. And the longest leg will take the list that we are looking at, and it will get the maximum value by something and the maximum value by the duration. Now you'll note that this is actually called max by or null, which tells us that this could be null, and it could be null for the same reasons as our method can return null, because there may be no elements in this list. So let's write these conditions. We are going to say when the longest leg, just write like this, when the longest leg equals null, we want to return null. So that's the case of the empty list. When the longest leg planned duration is greater than the duration, then we can return the longest leg, because that is a suitable candidate. Otherwise, we want to return null. Now we've got good tests, so let us, I'm going to say otherwise, I mean else. So we've got good tests. Let's just see whether that passes, and it does. Is it good Kotlin? I don't know. Well, first of all, it's a little odd that we're returning, so we can lift this return out of the when. That is almost my favorite version of this. And as we look at it, you can see here, this green tells you that Kotlin has seen that it's safe to call planned duration here, because longest leg can't be null, because if longest leg was null, then we've been through this branch of the when, not this one. Could we make this nicer? Well, some people would hate this variable here, and we can solve some problems, in fact, by piping this into a let. Move this over a bit, and there's a trick where you pipe this into a let, and then you give it the same name over here. If we do that, we can take this code here and move it into here. It's a little bit odd, but it is the same, running the same code. Now, this longest leg is unused, so we can remove it. And that does the same thing. And now we can move this return out. I don't think it offers it for us, but we can move the return outside this thing, outside the let. Now, the first case here is when the longest leg is null, and we return null. And that, if you think it through, is the same thing as saying question mark dot here. So question mark dot means that we won't call the let here, that this type will now be leg rather than nullable leg. If we run that, you'll see it works. And in fact, IntelliJ is telling us that it doesn't need to do this thing. That can go away, and if that can go away, that can go away. Then with only two cases, maybe it's simpler with an if, like that. When you see this formulation, this is in fact what takeif is doing. Takeif takes a predicate, which is this longest leg duration, and returns null, otherwise the thing on the left hand side. And that is it dot plan duration in there. Bit of a nasty refactor. Probably lay it out better, but it's the same code. I personally don't really understand takeif. When I see one, I always have to think what it's doing. So luckily we can back this out, and we can back it out by inlining takeif. And having inlined the takeif, we can also inline, well, we can convert this to an if statement, this question mark dot. And it's all a bit confusing, but we're going to call this back to our longest leg. Now, horrible as it is, if we invert this if condition and we inline this let, you can see the shape of this, and if we then just convert this back to a when, you can see we're back in the situation we were before, which is quite sweet, really. Finally, we don't have any Java clients, so we don't need to call this JVM name legs anymore. That can go. I think still that this is the sweetest version, so I'm going to commit it and say we're done. So as I say, this has been material from chapter 4, which is optional to nullable of Nat Price's my book, Java to Kotlin, a refactoring guidebook. If you've enjoyed it, I think you might enjoy the book. So there are descriptions how to buy it will be down there somewhere. Thank you very much.